Circle questions on the SAT reward a small set of facts used in the right order. Today we train the visuals, not memorization alone. If you can read a diagram quickly, you will save minutes on harder geometry items at the end of a module. We will move from center angles to inscribed angles to tangents, and then to angles formed outside the circle. Start with the cleanest rule. A central angle is an angle whose vertex sits at the center of the circle. Measure the central angle in degrees, and the minor arc between the same 2 points has the same number of degrees. Easy checkpoint. If the central angle is 72 degrees, the intercepted arc is 72 degrees, no extra factors. Now move the vertex onto the circle. An inscribed angle opens to an arc, but the angle measure is only half the arc. If the intercepted arc is 100 degrees, the inscribed angle is 50 degrees. Always divide by 2. Medium SAT tests often give you an arc and ask for an inscribed angle on the same arc, or the reverse. If 2 inscribed angles intercept the same arc, they are equal because each equals half of that arc. A tangent line touches the circle once. At that point of tangency, the tangent is perpendicular to the radius drawn to that point. That 90-degree relationship is your bridge into right triangles and Pythagorean reasoning. If a problem gives you a tangent length and a radius, you can treat the triangle as solvable with the Pythagorean theorem. Side fact that saves time: from one external point, the 2 tangent segments to a circle have equal lengths. That equality is pure symmetry. Store it for multiple choice when lengths must match. Harder setup. 2 secant lines from the same external point cut the circle and create 2 intercepted arcs. The angle between the secants equals 1/2 times the difference of the far arc and the near arc. If the far arc is 120 degrees and the near arc is 40 degrees, the angle is half of 80, which is 40 degrees. Label the far arc and the near arc carefully. The difference is what you have. 2 quick bonuses. An angle inscribed in a semicircle is 90 degrees, that is Thales. Also, 2 inscribed angles that intercept the same arc are equal because each one is half that same arc. A diameter always cuts 180 degrees of arc. So it is a useful reference when you chase angle measures. Common mistake: you treat an inscribed angle as if it equals the full arc and you forget the factor 1/2. If your angle looks impossibly large compared to the picture, pause and check whether you doubled something you should have halved. Esse ta tip. Whenever you see a tangent, draw the radius to the point of tangency and mark the right angle immediately. That one habit turns many circle problems into fast side length algebra. Recap. A central angle equals its arc. An inscribed angle equals half its arc. A tangent is perpendicular to the radius at the point of tangency. 2 seconds from an outside point, use the half difference of intercepted arcs. Practice more on NovaMaths.